Hello students, coming to the last session of the chapter stereochemistry, I'll explain about the structures of cis and trans decalene and norborane. Then conformations of 4 to 8 membered cycloalkanes and di-substituted cyclohexanes with example 1,2, 1,3 and 1,4 dimethyl cyclohexanes. So this session deals about the structures of cis and trans decalene and norborane, then conformations of 4 to 8 membered cycloalkanes and di-substituted cycloalkanes. Now, coming to bicyclic system, you would have seen somewhere in books that there are certain systems where two rings are fused together. Such systems are termed as bicyclic system, where our normal cyclohexane, cycloalkane, cyclobutane, cyclopentane, all these things are single cyclic molecule. But there are certain compounds where two rings are fused together, joined together. They are called bicyclic system. So molecules that contain two or more rings joined together can be called as bicyclic system. Two or more in the sense, more means it can be tricyclic also, and etc. etc. Now, what are the different ways by which we can express this bicyclic system? There are three different ways where the ring can be linked together. It can fuse together in different way. It is shown here. The first pattern is fused form, where the two rings share two carbon atoms in common. The second way of expressing that one is bridged, where it will share the two rings. Here there are two rings. This is of one ring, this is second ring. And in this second two rings, how many common atoms are there? Here we have one atom in common. Here we have one carbon atom in common. And also one ring is there at the top, at the apex of the bridge. So that is three carbon atoms are shared here. So this is called bridged bicyclic compound. Then here spiro, in this we have only one carbon atom in common. So these type of compounds are termed as spiro bicyclic system. This is fused bicyclic, for example decalene, bridged bicyclic, for example norborane, and spiro bicyclic compound, example spiropentane. Now, coming to the nomenclature of bicyclic system, for example, the previous decalene will take first. Decalene, how many carbon atom it contain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it contains 10 carbon atom. That is why decalene. So how to name this? Simple word naming is decalene, but IUPAC nomenclature will be different. So by attaching the prefix bicyclo to the name of the open chain hydrocarbon with the same total number of carbon atoms as in the ring. So simple way, again we can write it as bicyclodecane, because there are two rings, two cycles. So there are bicyclodecane. Then again the name is not complete because we have not mentioned how many carbons are there in each ring. So that too we have to mention. The size of the ring is specified by counting the number of carbon atoms in each of the chain connecting the two atoms that constitute the ring junction or bridge heads. Decalene has 4 carbon atoms in each of the two chains and none in the third. We'll take again the example. What we have to do? First, we have to mention the number of carbon atom in the first ring. Then mention the carbon atom in the second ring and mention the carbon atom in the bridge. In decalene, there is no bridge. So the number of carbon atom in the bridge will be 0. So how about the number of carbon atom in the first ring? It is 1, 2, 3, 4. We don't have to count this shared carbon atom only which is a part of the first ring. It is exclusively the part of the first ring. That will be 1, 2, 3, 4. There are 4 carbon atoms for the first ring. How about the second ring? Again 1, 2, 3, 4. Again 4 carbon atoms are there in the second ring and no carbon atoms in the bridge. So we can name it as decalin, can be named as bicyclo in bracket 4.4.0. 0 stands for no carbon atom in the bridge. There is no bridge. Decane. So this is the complete name of the decalin. Decane. Bicyclo 440 decane. Decalin is the common name. Bicyclo 440 decane is the IUPAC name. Now, coming to the conformations of decalin, cyclohexane are expected to be the most stable in chair form. We know cyclohexane has two conformations. One is chair form and boat form. In chair form, it will be more stable, that you are studying in earlier classes. Now, even for decalin, as it is a cyclic compound, it also prefers the chair conformation. But for decalin, two different ways of chair conformations are there. There are two possible ways in which two chair conformations of decalin can be joined. When the two rings are joined through two equatorial type bonds, trans decalin is resulted. Whereas, if the two rings are joined through axial equatorial union, then it will lead to trans decalin. It will be more clear in this structure. This is the way of representation of chair form of trans decalin. The two conformers of the chair form are cis and trans decalins. Okay, the single form will be cyclohexane. It can be considered as a two cyclohexane rings are fused together to form a decalin molecule. So the two chair conformations of the cyclohexane molecule, if the two are formed both at equatorial position, here it is axial, this is equatorial. So this bond is equatorial, and here again this is axial and this is equatorial. So here the two bonds are fused at equatorial position. It is equatorial fusing. That is trans decalin. Whereas in cis decalin, what is happening? Here this is the equatorial position, whereas this is the axial position. So this is equatorial axial fusing. That is cis decalin. So this type of the two conformers of decalin can be termed as cis decalin and trans decalin. In cis decalin, there is equatorial axial fusing, and in trans decalin, it will be equatorial fusing. Equatorial fusing in trans decalin, and axial equatorial fusing will give to cis decalin. Now, coming to the next compound, which is norborane. Here it is again a bicyclic compound, but in addition to decalin, there is a bridge. There is a bridge in norborane. It's a substituted norborane. There are two methyl group at the apex and one methyl group at the bottom. There are two methyl groups at the apex of the bridge and one methyl group at the bottom of the bridge. So here, why norborane? What stands for nor? The actual borane molecule has three more methyl group. So it is deprived of the three bor. Like this is the borane. This is borane molecule where we have three methyl group. So how about the norborane molecule? In norborane molecule, the three methyl groups are deprived. It's not there. Okay. So the 1, 2, 3 methyl groups are not there in norborane molecule. So that is called norborane. That is why the term nor stands for. Nor means it is deprived of the three methyl groups of borane. Okay. So this norborane, where we have the norborane like this. This is norborane, the plain non-borane. So in this norborane, we don't have any methyl group, whereas in borane, we have the three methyl group. Now here again, there is one, there is no methyl group attached to the apex or the bottom. How to know him in IUPAC system? How we can name the compound in IUPAC system? Here, how many carbon atoms are there altogether? We'll count this. Okay. Now here 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms are all together in norborane. So 7 stands for the term hept. So the corresponding alkane is heptane. Now only the name heptane is not complete. We have to add bicycloterm. We have to represent the number of carbon atoms in each ring and all. So the first ring contain how many carbon atoms? 1, 2. Second carbon atom contain 1, 2. And the bridge contain 1 carbon atom. So it will be bicyclo 2, 2, 1 heptane. It's shown here. Bicyclo 2, 2, 1 heptane. So norborane is the common name. Bicyclo 2, 2, 1 heptane is the IUPAC name. Now coming to the other cyclohexane, other members of cycloalkane family, which starts from are cyclopropane, cyclobutane, cyclopentane, hexane, heptane, etc. They all are planar molecule. And they possess large angular string. So to relieve the angular strain, cycloalkane assume a non-planar configuration. So what type of configuration? Each cycloalkane assume different configuration. For example, this cycloalkane is which one? Which contain how many carbon atoms? 1 here, 2 here, 3 here, 4 here. It stands for cyclobutane. This shape look like a butterfly. So we can say cyclobutane assumes a puckered or folded conformation known as butterfly structure. Butterfly conformation for cyclobutane. Cyclopentane assumes envelope shape, just like a cover envelope shape. So 1, 2, 3, 4, 5. 5 carbon atoms are there here in cyclopentane. Cyclohexane, this we know already, which you will be studying from PU onwards, that cyclohexane exists in chair as well as board form, and chair form is more stable than board form. It will be a chair shape and this is a board shape. Cyclohexane. Cycloheptane exists in easy chair conformation. Easy chair, somewhat slanting chair position. Which one occupies? Cycloheptane. How about cyclooctane? Cyclooctane exists in board chair, which is in equilibrium with crown-like conformation. Crown-like and board chair structure for cyclooctane. So these are the different forms. Why do they take all these shape? To relieve the angle strain in the molecule. If you represent plain molecule, there will be lot of strain in the molecule. To relieve that, everything is single bond. It always rotate, twist about each other. So it can take many different shapes. Now, coming to the conformations of di-substituted cyclohexane. Cyclohexane, plain thing, we know it occurs chair form as well as board form. When one substituent is there attached to the cyclohexane, then what position it will occupy? If one substituent is there, it can occupy any position, and that position is considered as the first position, just like benzene. But when one more substituent is getting attached, we have to compare that one with the first substituent. Then for that, before going to that, we should understand that in cyclohexane, there are how many hydrogen atoms attached? There are 12 hydrogen atoms attached. In this, how many or what is the direction of all these bonds? It occupy mainly two positions. One is like this, which is perpendicular exactly up or down. They are termed as axial hydrogen atom, and we represent that one as HA. The 6 hydrogen atoms which point along an axis through the molecule, are called axial hydrogens. So these all 1, 2, 3, 4, 5, 6. On each carbon atom, there will be one axial and one equatorial hydrogen atom. So this is Ha. And the other one, which is slightly slanted below the plane, it is termed as equatorial bonds, equatorial hydrogen atom. It is represented by He. Here we have one equatorial, here we have one equatorial, here we have one equatorial, here, here and here. So we have 6 axial hydrogen atoms in cyclohexane as well as 6 equatorial hydrogen atom in cyclohexane. So there are 2 different type of hydrogen atoms, and the incoming substituent can occupy either axial position or equatorial position. Now, when the substituent comes or occupy, and when we consider 2 substituted cyclohexane, for example, 1,3-dimethyl cyclohexane, 1,4-dimethyl cyclohexane, 1,2-dimethyl cyclohexane, etc., then these methyl group can occupy either axial position or equatorial position. We'll take 1,3-dimethyl cyclohexane, the different form. What different form? When it comes to different form, again the term conformations. When it comes to conformation, that will be cis and trans form. So how can we write the cis structure of 1,3-dimethyl cyclohexane? In cis 1,3-dimethyl, 1,3 means if one methyl group at this position, the third one should be 1, 2, 3 at the third position. So both should be either axial or it should be equatorial. Both methyl groups should be either axial or equatorial. Such type of structures are termed as cis 1,3-dimethyl cyclohexane. Whereas in trans form, one methyl group occupy axial position and the other one occupy equatorial position. Axial equatorial arrangement or equatorial axial arrangement. Both are same. So this are trans conformation and this is cis conformation. In cis, both methyl group occupy axial or equatorial position. In trans, both methyl group occupy axial and equatorial position. Different examples is 1,1-dimethyl cyclohexane. When it comes to 1,1, only 2 structures are possible. Both 1 methyl, one axial, 1 equatorial. It is the same molecule, 1 axial, only 1 structure, both are same molecule. Then when it comes to 1, 2, we have cis and trans. But 1, 1, we don't have cis and trans because only one type of structure is possible. Cis 1, 2, we can hear 1 axial, 1 equatorial or 1 axial, 1 equatorial. If both are axial, cis conformation, and if both are, one is axial and one is equatorial, it will be trans conformation. Then cis 1,3 and trans 1,3, which we have seen already in the previous slide. This is cis 1,4, again 1,4. It should be 1 and 4th position. Both should be up, axial position, and trans, one should be up and one should be down, which is axial and equatorial position. Now, students, in this session, with the last session, you would have understood about conformations of 4 to 8 membered cycloalkanes and di-substituted cycloalkanes with the example 1,2, 1,3 and 1,4 dimethyl cycloalkanes. And also you would have learned about the bicyclic systems like decalene and norborane and how you can draw the conformations of cis and trans decalene. And what do you mean by how to name the IUPAC naming of decalene and norborane?